Let me give you an example. Actually, the following example is not relevant to the assemblies. Somehow it is considered as the opposite of assemblies. Then we will finish the session. Last session, in the project that I showed you, most of our sloped roof, let me open this file, and the curtain walls, as you can see, they were slope glazing. I mean, we were using sloped roofs which were made of glass. So in other words, the slope glazing. Actually, assembly has got some shortcomings at this context that I'm gonna deal with this context and explain it, and then I'm gonna introduce the alternative way that you can use. That if you were using assemblies and you couldn't manage to solve your problem, you can use the another way. First of all, I sketch a roof by this way, as you can see, and then by using a slope arrow, I uncheck define the slope. I pick slope arrow by this way. I sketch it unprincipled, and as you did see, it was not technically sketched. I just wanted to use a slope arrow here. Check this out. Here is the result. After that, I open the level plan view. I mean site plan view, and then I modify the type. I choose sloped glazing by this way. Let me change the layout, fix distance by this way. Then in the layout of grid 2, fix distance. Here is the result. Very well. After that, I'm gonna display these in the sheet, on the sheet, while it is zoomed to extent. Before that, let me create an assembly. I choose these elements, then I create an assembly by this way. For example, roof 01. I create the assembly, and then I create views. Check this out. I want you to check the view and then tell me the problem. I mean, what is the problem of this plan detail view? Let me zoom in. Check this out. The problem here is that, let me place a dimension or measure the dimension here by this way. Here the problem is with the dimensions. Here, as you can see, the aligned dimensions are not similar, are not identical, while I adjusted the panels equally. Here, the reason is because we are viewing the roof from the top, and when we are looking at this slope glazing from the top, the view cannot be perpendicular to the surface of the slope glazing. Therefore, the dimensions that we are checking them are not correct dimensions, and this is the problem, or which has caused problem. So at such a condition, what should we do? First of all, I should say that assembly does not work out at this condition. I mean, it can't handle this situation because it is revealing its shortcomings. For instance, here if I add a detail view or section, by this way I sketch the section line. Very well. Here if I add the detail views, watch this part carefully. Detail view will be added here, as you can see, detail view detail 1, which shows that we can add views. In the continuation, I'm gonna give you the solution, and then I will talk about the assembly. Very well. Right here in project browser, I open level 1 plan view, site by this way, and then I select the assembly to disassemble it. For now, I click on disassemble by this way. Then I want to place a spotter slope to figure out the slope of the slope glazing. Check this out. Here is the slope line or slope spot or spotter slope. However, I can make it more complicated by moving the place of the slope arrow. As you can see, the slope is not distributed identically. By this way, I change the position, and after that, I'm gonna sketch a reference plane parallel to the line of the spotter slope. By this way, the reference plane is parallel with the line of the spotter slope. By this way, as you can see. Well done. After that, I'm gonna sketch a section line parallel to the reference plane or to the line of the spotter slope. It does not make difference. Guys, do you remember the question? Let us have a review. Here we are looking for a view from the slope glazing which is perpendicular to the surface of the slope glazing. Since plan views are not practical at such a condition, And then I open the section view, and then here, as you can see, we are viewing the object as an ordinary sloped surface. Check this out, an ordinary sloped surface. Very well, then again I pick reference plane, I sketch it right here. Then I want to align the reference plane with the roof or sloped glazing. Since I want to make sure that the reference plane is matched with the sloped glazing, move it. Right now we need a view which is perpendicular to the reference plane. Here, if I want to sketch a section line, as you can see, it is not allowed here, but no matter, we can sketch the section line and then rotate it by using rotation tool. Check this out, and then I want to align it with the reference plane. Check this out, I align these with each other. Right now let's check what has happened. Check this section line. Let me show you in the project browser. As you can see, we got a social section view, but in fact here we are given a plan view which is perpendicular to the surface of the slope glazing. Check this out, the dimensions are equal. As you can see, we have opened the view of this assembly. By this way, we just wanted to have a view from this object separately. So again, I select the sloped glazing, then I create an assembly. Okay, check this out, I specify the type name. Okay, then I right click to create assembly views. Okay, well done. Let's check it out and let us have a review. Again, I place the spot slope just like before. Then I want to sketch a detail view line, and as you can see, the sketch detail views are saved as detail item. As you can see, detail view, which doesn't make any difference. Well done. I mean, here the name is not section 1, for example, or section 2, but we're allowed to rename it. But the above functions are the same. Very well, then I sketch the detail view parallel to the spot slope. Just like the previous example, let me open the detail view, check the result. I enlarge the size of the view by this way, by extending the shape handles. Very well. I adjust the scale 1 to 100. Here is the result. And then, as I told you before, we need one more section view or section line. However, the reference plane is not required. By this way, after sketching the section line or detail view, I want to rotate it like this way. I place it right here, and for place it more accurately, I rotate it in relation to the specified point right here. By this manner, I put it right here after the rotation process. By this way, right now the detail view line is parallel to the slope glazing. Well done. Let me open the detail view. Check this out, detail 1. Here is the result. Then I choose the detail 1 view and then I rename it. I specify, for example, plan for the sloped glazing. So practically we got the plan view of this object, which is parallel to the object or to the surface. And if I measure the dimensions here, as you can see, they are equal to each other. However, there are some small differences between working with the elements which are assembled or disassembled. All in all, I want to say that this is an important feature of the assemblies that I tried to explain it completely for you, and we use it during our modeling process.